Hi everyone, Piet Callemeyn here. I hope you're having an awesome day. So welcome again to a new video in the Wearable design project. Today we're going to talk about the PCB layout. So as you know by now, we are making a wearable heart rate sensor. In our previous videos, we have tackled the system architecture design. Today we are looking at the PCB layout, how to put this in a small footprint size. That is typically always the challenge that you have in a wearable design project. There is a relatively small housing that is available, can be either off the shelf or custom, and you have to be able to fit your PCB in it. Now, this is, for instance, on the lower right, an extreme example, of course, of a rigid flex structure in a very small housing. We will not work with such a very small housing in our project today, just to make it understandable, but I will show you a couple of options to go with a rigid design or a rigid flex, depending on the needs in your projects. So let's dive into it. So this is the status where we left our schematic design, the system architecture. So first we looked at the sensor itself to do the heart rate detection. It has built-in LEDs, there's separate power supplies. Then afterwards we have been looking at the design of the microcontroller and connectivity. And then we have been looking at the power design. So there's a battery charging IC, and then there's also a buck boost DC-DC converter to enable us from the 3.3 volts to generate our LED voltage, which is at 5 volts. We need a 1.8 volts and a 3.3 as well. So that is where we are. Today we are going to add a new PCB layout to that project. And I will go ahead and import all the changes. So importing all the components that we have. So right now what you see is that we have all the components in here. Now an easy way to start placing is to use the placement within a rectangular room. So maybe let's start with our microcontroller and connectivity first. Here the schematic of that one. So I'll go ahead and select everything. If you have set your cross probing to be on in Altium, you'll see that this is automatically selected in here. What I'm going to do is via tools, component placement, arrange within a rectangle, I'm going to define Altium to place everything over here. So that makes it easy to have everything that was in that room relatively close to each other. So then the next step is to start with the placement of this. I will go ahead and shift out, let's say, the bigger components, the more bulky components. And what I also will do is I will change the text size for all the components because this is way too large. Typically what I always do is I try to put the components close where we need them. So these are the ones that should be placed close to pods. They are selected over here, and I will go ahead and place them close to the microcontroller. Okay, so this is a very initial placement that I have done. Basically the components that need to be close are close. The bigger ones, I'm shifting them out. We'll have to see in the complete design where they fit in. Then next up is our battery charger. To do the placement, so I'm going to select this first. We go into the layout, then you go to tools, component placement, arrange within a rectangle, and then here's everything that you need. And then again, I'm going to do the same thing. I will place the components as close as possible on the most logical places where we can put them. So that's it for the placement for now. Again, everything is relatively close or as close as possible that I can get it. Next up is the boost DC-DC converter. Again, same thing over here. Going to select everything. It is now cross-probed in my PCB layout. Placement, we arrange them within a rectangle. I want them close to the battery charger over here. So let's go ahead and do the placement for this one. So this starts looking nice. You see with using the BGAs, of course, we have a very small footprint. If I use the probing here, this rectangle is only 7 by 6 millimeters. So this is all very small. If we're then going to combine it or place it closer here to the battery charger, you will see that we have a very small system. What we see is we have our power management system over here. It's relatively small in size. Then we have our connectivity and control over here, small as well. I'm tempted to put one on the bottom, let's say this one on the bottom and this on top, to make sure that we have a small size as small as possible. Then of course what we are still missing here in this design is our sensing. So that is in here. I will put that on the side for the time being. And there I would like to give you an example of what things could look like, let's say if you're going to use a flex design. So for now I will put it on the side, and in a second video I'm going to show you how the flex design would be done and would look like. So same trick again, arrange within a rectangle. I'm going to place that over here. I want to have the lowest number of components as possible over here, because we're going to make a small rigid part of this thing. Then there will be a flex connection, and then on the other side there will be connectivity, control, power. So for starters, this is what I would do for the PCB component placement. I'm going to alter the board shape already a bit to make things a bit more compact. Okay, here we are. So next thing for me, I'm going to shove everything together so that it is as small as possible. So I have put everything a bit closer here in the power part and also on the microcontroller side. If we look in 3D, let's have a look what it looks like. What we immediately see is this is a very bulky connector. So it's a standard JST connector, 3-pins connector. What I will do here is, typically in such a case, we will have an assembly where the battery is more directly assembled to the PCB rather than with this type of connector. For prototyping or for larger boards, this is something that could work. For us today, this is really too large. Also, what I see over here is then that other pin. This was a breakout, UART breakout for the control and connectivity here. Again, this is large, too large to my liking for this project, so we'll have to get rid of this. What we're going to do with the JST is maybe we'll make a variant where it is not being placed. And then if you swap over to that variant, you see that it's only the pins that are left over. Now we also see the USB, we have to shift that one, of course, so that it makes sense. And then we can alter the board shape to put it just at the edge of that PCB connector. So it's all becoming relatively small footprint, I would say. This is a micro USB connector, so you can gauge the size of the whole system based on that. What I would like to do is to put this controller on the other side here, a bit depending on, because we're working with BGAs, where that can be still placed. So that is something that I would look at. And then my question as well is, do we still need these switches? This we are going to get rid of in here, because we also have the programming header where we have that one available. So let's take this one out as well. And then we have this compact solution. Now next up, we will place this one on the bottom side, so it will become smaller. And then we're going to design the rigid flex for this. So again, I always start with the placement. If the placement looks good, the layout, the routing will be more easy to do. In this case, we have, let's say, the rigid flex challenge as well that we want to look into. So there we need to take into account or make some smart choices, I would say, with our sensor. So a couple of things to think about. In the next video, it will all come together in terms of routing and flex, but this is really where it starts. It's always important to spend quite some time here to do the placement in decent blocks and then work from there onwards. So this is the end of this first video on the PCB layout. In the next one, we will further develop it and focus on the challenge of flex PCB layout. Looking forward to seeing you there.